Dear fellow coders, welcome to Untitled Coder. AutoML, which stands for Automated Machine Learning, has become quite popular these days. There are a lot of companies that has raised good amount of funding because they are doing AutoML framework, and there are a lot of open source libraries also doing AutoML automated machine learning. So in this article, what Piotr Plonsky, who is also the creator of a very popular machine learning AutoML framework, has done is that he has tried to compare AutoML frameworks on 10 different tabular computations, Kaggle computation. So this video is primarily taking this article and giving you the related information about AutoML comparison. If you prefer reading this article, I have linked this video. I've linked this article in the YouTube description. You can go ahead and read it. Okay, so to quickly say what are the AutoML frameworks that we are going to compare is something that you can see here. So Autoveka, Autos sklearn stands for scikit-learn, Teapot, H2O.ai as a company has got a driverless product, that is a paid product, but H2O.ai as a company also has got a bunch of packages, open source packages, and they've got an AutoML package. Google Cloud AutoML table, if you have GCP, you can access it. AutoGluon is another open source package, and MLjar, which is actually something that Piotr has created. So this article talks about taking all these AutoML frameworks, these popular AutoML frameworks, and comparing it with 10 tabular Kaggle computation. So what does 10 tabular Kaggle computation means? Kaggle computations might have tabular data, or not tabular data like computer vision or some media data. So what this author has done, Piotr has done in this case, is take 10 Kaggle computation, especially tabular computation, and compare it with these AutoML frameworks. And what are the computations that he has picked up is something that you can see now. So the Mercedes-Benz computation. So you can see that there is a Mercedes-Benz manufacturing, and the task is regression task. And then the Sandner value prediction challenge, and task is regression. Allstate claim severity, task is regression. And you have got a bunch of binary task, which is a single binary classification. And then you have got multi-class classification, Walmart recruiting and voter group product classification challenge. And you can also see the metrics that is used for evaluation of these computations. So whenever there is a competition on Kaggle, so there is an evaluation that is going to happen, like you're going to get a final score, and that score is usually based on this metric that is announced upfront before the competition. So people who are trying to do or win this competition, they would optimize their algorithm for this metric. And when did this competition happen? How many teams participated? How many rows were there in the data? And then how many columns were there in the data? So this is the information. So we have 10 competition: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we got 10 competition, and these competition were picked up from this article, which is actually you for AutoGluon. So this was an article introducing AutoGluon tabular, and those competitions have been picked up by Piotr to showcase the comparison of popular framework. And there is a small disclaimer that I would like to add. At the end of this video, you might see that MLjar as an AutoML framework that would come at the top for a lot of these computation, like with good score. And MLjar is a package or library created by Piotr. So I'm not saying that there is something going on, but I would like to highlight this as a fact, because a lot of times whenever we do this comparison, it's quite simple and easy for us to miss these hidden details. Having this hidden detail would help us be skeptical always, and then also explore further. Okay, let's get started and then see what are the results look like. So we have 10 competition, and then we have 1, 2, 3, 4, 5, and 6 and 7. So we have 7 AutoML frameworks. So 7 AutoML frameworks when compared against 10 competition from Kaggle. And the author's reason for why he picked up Kaggle data set Actually, Kaggle dataset, usually these are companies sponsoring a particular competition. Like this is like Mercedes-Benz, this is like Santander. So these are actual companies sponsoring this competition, and then people actually winning thousands and thousands of dollars as prize money. So this would most likely replicate a real world problem. So that can actually tell us how AutoML can help in real world. And the next reason is the comparison that has been done here as part of this analysis is on private leaderboard. So Kaggle usually has got if you're familiar with Kaggle, for any competition you have something called a public leaderboard and you have something called a private leaderboard. Public leaderboard would try to evaluate your machine learning model on a very smaller subset of data. It wouldn't use the entire data, and private leaderboard is the actual reflection of the entire data, how your model is performing well. How does it matter? You could be optimizing your algorithm for public leaderboard very hard, but it is entirely possible that you are actually overfitting, and then when you go to private leaderboard, you are going to see a big shake up. That's what Kagglers call it, big shake up. So that's why private leaderboard, which means like the solution is also like on the entire data set. So that is another good thing why the author has used Kaggle. And regarding the machines, the computer that was used for this analysis is it was trained on EC2, Amazon EC2 machines, M5 2x large machines, 96 CPU, 384 GB RAM. You can assume that the amount of computation power that is required for this kind of piece. Then training time was set to 4 hours. So this detail is applicable except for GCP tables, because they are using their own machine type, and then you don't have control on the machine, because everything else is like an open source package. It's a Python package, you can just install it and then use it, except Google Cloud AutoML table, which is part of your GCP package, or you need to have GCP credits for you to do it. So given that this is the situation, this is how the final result is going to look like. And how do you read this result? So the score that you see is actually a percentile rank score. So what does it mean? It means if you imagine like there are 1,000 people who participated in a competition, the first rank, whoever gets like 1.0 as a score, 1.0 as a score, that is like the best solution, and that's like the first rank. And whoever has the worst solution, their rank is 0. So anything in between you can see from best to worst, from like 1 to 0, which means higher the value of the score is better. So whenever you see a higher score, then the value is better, and like that is what we are going to see here. So how this thing has fared, that's what we're going to see here. So the author has tried to highlight the best score, but you can have a look at it yourself. So higher the score is better, and it is from 0 to 1, and it is what you are seeing is a percentile score of a given competition. So like you cannot compare two different competition now, because the number of participants for different competition would change. You're like this is like 5,000 people had participated, so like 8,000 people had participated, this is just 1,000 people had participated. So this would change, but what the fact what doesn't change is how better this particular AutoML package has done in a given competition. So we have got 10 competition, 7 AutoML packages, and if you actually see, MLJAR has been a consistent performance in a lot of these competitions, which is a good thing. You can see like especially for these competitions, like the ones at the bottom here, you can actually see the AutoML solution has got like more than like 90th percentile. Which what does it mean? It means these AutoML solutions, for example, let's take BNB Paribas, okay, the competition that we just saw here, which is BNB Paribas Cardiff Claims Management. It's a binary classification problem, and then the evaluation metric was log loss. So in this competition, if you had used only AutoML solution, right, you have used only AutoML solution, either AutoGluon or MLJAR, you are placed in the top 90th top 2 percentile. So what does it mean? It means you would have easily hit a silver medal, most likely. I assume in this case you would have easily got a silver medal on Kaggle For this particular competition, if you had just simply used AutoML, you didn't have to do anything else yourself. Just simply using AutoML solution would have gained you a silver medal in this competition, and probably in all these other competitions as well. It would have got you at least a bronze medal, which is I think usually awarded for top 5% or something around like that. So what does it mean for AutoML fans like me? One, AutoML actually works a lot, and when you compare it with the different solution, you can actually see AutoGluon has been a consistent performer for a lot of this competition, and like the winner that you see in this case is MLJar. But what I would suggest is, like, I have huge respect for the author Piotr who has put it together. No offense for this analysis, I highly respect this analysis, but still what I would say is that the way every AutoML algorithm works is different. Something would require a lot of computation power. For example, not every day you are going to have a 300 GB machine for you to run AutoML forever. So there are instances where like for example, to give you a sense, H2O can give you a better result. Like in my personal life, I have won a hackathon just using simple H2O. I'm not saying that is the best, I'm just saying that you need to pick the AutoML solution not just purely based on the highest score that you can get, but based on lot other factors, like how much computation power is required, how much information this AutoML is going to give you regarding what is going on behind it. So all these things. So overall, MLJar has done a really good job, followed by AutoGluon. And then you can also look at other solutions as well. Like for example, if you already have a GCP ecosystem, then GCP is really good. And if you want a solution that can be easily productionized, H2O is good because H2O can give you the jar files that you can put it in your Java production system, so that moving like the model to production is quite easy. AutoWaker, I'm not sure if it is such a popular AutoML framework. Like maybe it was just added. AutoScikit-learn is another simple package, but there are like other packages as well, like AutoKeras and a lot of other packages that could really give competition to this thing. AutoGluon is actually definitely a promising package, and MLJar is from the scores we can actually see MLJar and AutoGluon are very close, and MLJar is actually a very good contender for AutoML solution. So that's what this table actually tells us. But what I'm most interested is looking at these competition. AutoML is really a very good way to start your baseline. If you are going to participate in Kaggle competition, or if you want to build a machine learning solution for your own organization, AutoML is definitely a very good way to start with a baseline. Like then you can pick the best model and then you can start tweaking it. But instead of you doing all the heavy lifting, to start with, like a lot of data scientists, if you see, they usually have a pattern, right? Somebody would start with a logistic regression, or somebody would start with a random forest with a baseline parameter, and then they would start optimizing their hyper parameters, and then they would improve their score and probably move on to different algorithms. But having an AutoML framework can really help, and that is what these scores really indicate. And these scores are really visualized here. You can see blue color, MLJar being quite at the top for a lot of these competition. Once again, this video has nothing to do with MLJar, or it's not being sponsored by MLJar or anything, but MLJar really looks like a nice AutoML package that you should check it out. And that probably takes us to the end of this video. So I want to wind up this video, giving you some information about, or my experience about AutoML. First, you might wonder, why do you need AutoML? Like let's say you are a data scientist, or you are a machine learning engineer. Why do you need AutoML, right? See, according to me, if you ask me, as a data scientist, I would be more interested in solving the problem that I'm trying to solve, rather than doing a lot of trial and error. So what AutoML does is, for me, is it actually takes care of the trial and error process. It actually builds, like, let's say, like 100 models, 150 models to 100,000 model or 2000 model, like how many number it is, and then it is going to tell me these are like the top 5 best models. And now, based on my organization situation, my necessity, what is better for my company or what is better for my development environment, I'm going to pick something from that, and then I can start building on top of it. So that is the biggest advantage AutoML has got. The second biggest advantage is not everyone is actually let's say a high-end data scientist, like somebody like like 4x Kaggle grandmaster or something. So if you do not have a very strong data science team, let us say, but you still have problems and you want to solve them, maybe like you have got software engineers, maybe like you have got a bunch of people from DevOps who wants to try this thing. So what do you do now? Like you don't, like, you want them to understand all this stuff, but you cannot send them to do 2 years graduation in data science and then come back. And that is really where AutoML is again really helpful, because all if you want is a baseline model that gives a decent accuracy, like we just saw for a few competition. It was even the top 5 percentile, top 2 percentile, right, rank, not based on the evaluation metric. So in that case, your AutoML can give a very good decent baseline, and your software engineer can build it, your DevOps person can build it. And then third, a lot of data science projects usually start with POCs, and I don't want my team to work weeks in creating a nearly good model, not maybe the best, nearly good model. And if that is the case, I would probably fall back to AutoML model, and then ask them ask my team to use an AutoML framework, build a model, pitch it to my stakeholders or sponsors, and then win the project and then move forward. So these are some reasons why I at least would use AutoML, because I strongly believe that a data scientist time is well spent in solving the actual problem, rather than spending time in creating 10 different models or 20 different models or 30 different models. If your job requires you to do that thing, that is fine, but in most cases I think this is effective. And one final call out about ML jar. So according to this author, who is also like I said, the creator of ML jar, Piotr Plonsky, ML jar is more transparent. So a lot of AutoML models, if you see, the problem is you actually do not know what is happening behind the scene. There are a couple of like libraries. For example, if you take H2O as an example, I have seen H2O giving very good detailed information about the model that is being built, and ML jars, which is that. So biggest advantage of ML jars AutoML framework is its transparency. Like you can even see in this animation that you get to see sharp importance, which is sharp is a way to interpret your model, and then you can also see then it is building your graph, and then this is quite easy for you to explain it to your business stakeholders about what is happening, why a particular variable is important, why a particular variable is not important, rather than just reporting the evaluation metric. This could also mean that you are doing a job that business people can connect with. So that way MLJAR looks again like an exciting prospect. I would probably try out MLJAR soon, either on a Kaggle competition or just on a data set, and then I would try to make a video out of it and then share it with you. And if you have never used AutoML packages, I think this is high time for you to try out AutoML packages. AutoML packages are really awesome, and you should really try your luck with the AutoML packages and see how it works out, especially in an organization setup, how it is being received, or all those things. I hope this video was helpful to you in getting started with AutoML, or at least to know about AutoML, and then to which AutoML library that you should be using more frequently, or if you want to start with a baseline model. AutoGluon and MLJAR are the leading contenders according to this table, but also there are a lot of other AutoML packages that is left out in this analysis. PyCaret is a very popular package these days. AutoKeras is another popular package. There are a lot of other packages like this that is not part of this analysis, but according to this analysis, these AutoGluon and MLJAR are two good framework. You should definitely check it out, then see the performance of AutoML packages. Thank you so much for listening to me. And thanks to Piotr for putting together this article that has served me as a video content. And if you like this article, please go ahead and then give clap on Medium to Piotr for this article. And if you like this video and you thought it is helpful, please give me a thumbs up, and ask your friends to subscribe to the channel, and let me know what are other kind of videos that you would like to see on this channel. Thank you so much, and I hope you stay safe.